So we have a general understanding of atoms. They have a nucleus, protons, and neutrons, and then the outside we have electrons, okay? So then it comes to this idea of ions. Now, atoms are electrically neutral because they have the same number of protons as they do electrons. Now, when you have an ion, they either have a positive charge or a negative charge. So how do you get that, right? Now, for an atom to be called, for example, helium, it has to have two protons in it. So if you want to make an ion out of helium, you either have to add electrons to it or take electrons from it. That's the only way to do it and have it still be helium. So when we're making ions, we're not messing with the nucleus, we're just messing with the electrons. So cations have a positive charge, right? So if cations have a positive charge, that means there's more positives than negatives, right? Which means it had to do that, it had to lose electrons because it can't lose the protons. The protons are in the nucleus. So you can lose electrons from the outside and make an ion out of something. On the other hand, for anions, these are negatively charged ions, then they have to have more electrons than they do protons, right? So the positives and the negatives, there's going to be more negatives. So you do this by adding electrons, and you make cations by removing electrons. Okay, so chlorine. So what is the charge? And get rid of this 37 up here. Don't need to know that. What is the charge of a chlorine atom with an extra electron? Okay, so to do this, we have to go to our periodic table. So we'll scan back up here, and we'll find chlorine. Chlorine is a halogen. It's in group 7. So maybe you've spotted it, 7A. Maybe you've spotted it by now. It's over here, right? It has 17 protons. So going back to here, chlorine has atomic number of 17. Now, in order for it to have a negative charge, right, it's going to have 18 electrons. Now, that's 17 positives and 18 negatives, so the charge will be -1 like that. So if you wanted to write the symbol for chloride, right, you would write Cl minus like that. So this is what we know as the chloride ion. So sodium chloride of the table salt that we eat, that's a Cl minus. It's actually a chlorine atom that's gained an electron to become an ion. Now let's look at copper, and again ignore this. I've rearranged my notes. It's actually something for later. What is the charge of a copper ion that has 27 electrons? So in order to do that, what we have to do is go up into our periodic table and find copper and figure out what its atomic number is. Now I'll give you a hint. It's in the middle, and it's a transition element, or it's sort of towards the right side of the middle section, okay? So you need to find copper, and then what you'll find out is that it's this guy right here, right? It has 29 electrons. So go back to here, and again, in your book you'll have a periodic table, so you can just keep your book open to the end or the beginning, wherever your periodic table is located. But there's atomic number of 29. Now the electrons is 27. So it's 27 positives and 29 positives and 27 negatives. So what does that mean its charge is? Its charge is going to have to be +2. So the way we write that charge like this, when we write the ion symbol, what we actually write is Cu, and then some people are sticklers for this, I don't really care, 2+ like that. You would think it would be Cu +2, but what they like to think of is 2+ because it's 2 positive charges, okay? Right, so in order to figure out what the ion is, all you have to do is know what the number of protons is and the number of electrons, and you can figure it out. Or you could also know what the charge is and then figure out the number of electrons from that. So, for example, let's say I have, let's see, calcium 2 plus, right? And I want you to tell me what the atomic number is and the number of electrons. So we're going to go over to our periodic table, right? We'll find calcium. It's in the left. It's a metal, right? So it's on the left-hand side, and it has a. It's in group 2, right? So it's this guy right here, and it has an atomic number of 20. So going down to here, I can fill this in. Calcium has 20 positive charges. Now, how is it going to be that it has 2 plus as its charge, right? It means it has to have fewer negative charges than positives. So we'll end up having 18 positives down here, or 18 negatives down here. And that will give us the 2 plus charge. So you can know the charge, and then from the protons, you can figure the electrons out, or you can know the number of electrons and protons and figure out what the charge is. There's a lot of different ways that you can work with this information. So what we're going to do is fill in this chart, at least partially, okay, and see if we can get some practice. And then I'll just fill the rest of it in. I'll pause the video and fill the rest in. You can sort of check yourself. So let's say we're going to do the first two. So sodium, right, and it has 10 electrons. Again, we have to go back to our periodic table. So what I thought I'd do, instead of scanning back and forth, I went back to that P-table website, and now we can find sodium. It's in group 1, right? So you're going here, sodium is Na. It has 11 protons in it. Okay, so now what we can do is we can go back to our table, and for sodium, the number of protons, we put 11 like that. So it has 11 protons and 10 electrons. So it has more positive than negatives, right? So its charge is going to be +1. If you wrote it on the symbol, right, you would write it as Na plus like that. Now, for this element, I didn't give you the symbol, right? So what you have to do is use the number of protons, because the protons helps identify which element it is. So we're going to go back to our fancy periodic table, and sorry, my computer's acting funny. Look for 24 protons, and so we're just going to go along until we get to 24, and that's chromium. It's this guy right here. So going back to here, this is Cr, chromium. 24 protons. Now it has a +3 charge, right? So what does that mean? It has more positives than it does negatives, right? So that means in number of electrons, it has to have 21 electrons. The symbol for chromium 3 plus would be written as Cr3 plus like that. So what I want you to do is fill in the rest of the table, and then I'll fill it in while the video's paused, and then when you start it, the answers will be there. Okay, so I went and looked up protons for bromine being 35. It says it's neutral, so 35 electrons must have 35 protons. So it's bromine. That's element number 35, and so the symbol would just be Br. And then for strontium, right, its atomic number is 38, which means it has 2 more positive charges than negatives, and so it's a 2 plus, so that's strontium 2 plus. Now, the next topic to cover is something that we call isotopes. An isotope is an atom of an element that has a particular number of neutrons in it. So what we had talked about earlier is every atom of an element has the same number of protons. But as it turns out, they don't have to have the same number of neutrons. So isotopes are atoms of an element with different number of neutrons. Okay, so have a different number of neutrons is what I meant to put down here. Have the same number of protons, though, because they're atoms of the same element. So there's this thing called the mass number, and the mass number is when you take the protons and the neutrons and you add them together. Now, thinking back to what we said before, all the mass of an atom is in its nucleus, which is the protons and neutrons. So we call that total the mass number, because that's where most of the mass comes from. So the symbol that it's given is A, and this is just P plus N. Okay. Now, there's a symbol, it's called the nuclide symbol. The nuclide symbol is just the element symbol, but it reflects the mass number as well as the symbol of the element. So when I had the chlorine earlier, it had a 37 up here. That 37 is where we're placing the mass number. So the periodic table gives both the atomic number and the symbol. So chlorine is element number 17, right? So if we go back to our periodic table, element number 17 is chlorine. So that means chlorine has 17 protons. If it has 37 as the mass number, remember this is P plus N, and this is just P. If you just subtract those two numbers from each other, you'll get 20. This must be equal to the number of neutrons. So to check yourself, to make sure you have it right, 20 plus 17 is 37. Okay, so protons plus neutrons equals the mass number. Let's do another one. I got a little bit ahead of myself. Let's do copper 65. I think that was the one that I put up before. Oops, sorry. Cu 65. And what I want you to do is, following this example, look up the atomic number, and then you tell me what the number of neutrons is in that element. So I'll pause, you can go do that, and then when you restart, I'll have the answer. So there's the answer, copper 65, right? Copper's atomic number is 29 from the periodic table. So 65 minus 29 is 36, which is the number of neutrons. So why don't you go ahead and draw the nuclide symbols for carbon 14, and then an atom with 12 protons and 13 neutrons. Okay, so we'll pause for that, and I'll let you do that. Just as a reminder, right, this is going to help the number of protons is going to help you find the atomic symbol. Okay, there we go. Okay, so I solved these two for you, right? You have carbon 14. 14 is actually the mass number, and I think I might have forgot to say that before. So the 14 is the mass number. You can write it like that, or you could write it like that. So those represent the isotope of carbon that has a mass number of 14. Now, and the atomic number is 6, and you can look that up on the periodic table as well. So an atom that has 12 protons and 13 neutrons, right? In order to do that, you have to go over the periodic table. And when you do that, what you find is that element is magnesium here, okay? And then we'll go back to here. That gives me the 12, right, gives me the symbol, and then if it has 13 neutrons, 12 plus 13 is 25, so that's my mass number right there. Okay, so I have a little bit of a confession here. I just stole this off the ptable.com site, so I'm referencing it because I actually didn't edit out some stuff that's underneath there, so I thought, well, I'll just cover it with the periodic table since I need it for this next discussion anyways. So yeah, when you get to your section of the notes, you'll see some stuff that I had already talked about. You can, if you want to, just like I did, you can copy and paste the periodic table right into there. If I don't want to copy theirs into the notes that I give you because I feel like that's kind of like stealing their stuff, even though I'm using it here in lecture, okay? Now, so there's something called the common ions in the periodic table, common ion charges. And it turns out one of the periodic properties of elements is that many of them will form the same ions, and we can pull that out from the periodic table. Now, I'm going to explain it like this. The noble gases are particularly unreactive because they're happy with the number of electrons that they have, right? So, for example, helium doesn't react, it doesn't form ions very often. It actually has two protons and two electrons, and it's happy with that. Very stable. Okay, that's why again it's not reactive. Neon, argon, krypton. There's something special about the numbers 2, 10, 18, 36, 54, and 86, and we'll talk about that. Actually, go into that later in this semester. Actually, next week at this rate. So, having said that, the atoms want to be like, okay, the noble gases. And if they're close to the noble gases, it turns out they'll always form the same ion. So, for example, if you look at fluorine, right, it's way over here on the edge of the periodic table. It has, I didn't mean to quite do that, fluorine, it has 9 protons and 9 electrons. So how many electrons does it want? It wants to have 10, which means, right, because 10, it could be like neon, or it could be like helium, but to be like helium, it has to lose from 9, has to lose all the way these down here and get to helium. Much easier for it to just add an electron and become like neon. So it turns out chlorine's the same way, right? Because it has 17 and wants 18. Bromine has 35 and wants 36. So on the periodic table, for the nonmetals, just the nonmetals, all of these in this group make a -1 charge. Now, if you have a periodic table, you can write that on there if you want, the nonmetals. Oxygen, what will it do, right? Well, oxygen has 8, but it wants to have 10, right? So what it's going to do, it's going to steal 2 electrons from somewhere else, usually a metal. We'll talk about that later. And you end up getting a -2 charge because it needs 2 more negative charges to be like neon. Nitrogen typically makes -3, and carbon makes -4. Now, that's just for these green ones on the periodic table here, the nonmetals, okay? Everything else in between is kind of in between, so the amount of electrons they gain or lose will be a little bit different. The other ones that you can predict all the time what the ions they'll make are in groups 1 and groups 2. But you need to see both sides of the periodic table for this. Lithium, right? Little lithium over here, has 3 protons and 3 electrons. Now, if it wants to be like a noble gas, it could pick up 7 more and be like neon, but that's a lot of stuff for a small atom to be holding. It's much easier for it to go from 3 down to 2. Now, you don't think about this because we always see this periodic table, almost always see this periodic table laid out like this, but if you were to connect the periodic table, like cut this out and connect it at the ends, what you would find is you can connect 3 to 2, 11 to 10, 19 to 18, and you can actually form a cylinder that just makes a spiral that goes like this around the outside. Okay, so it turns out the elements on the left side of the periodic table, even though in our head, because of the way we display it all the time, looks like it's far from the noble gases, it's actually right next to them in the periodic table in terms of numbers. Okay, so lithium will lose 1 to be like helium, right? What will sodium do? Well, sodium's got 11. If it loses 1, it can be like neon, right? And so, that means as a group, group 1 tends to make a +1 charge. Now, beryllium, right, has 4. It's easier for it to look like helium. So if it's going to make an ion, the most likely charge is going to be +2, like that. Okay, so +2, right, group 2, +1, and group 1. So those ones are easy to predict from the periodic table. And those are the charges that they always take. Now, there's a handful of others that do the same thing, okay, and I'm going to draw those into the periodic table. And the way I do it is I just usually make a triangle like this, okay. Now, a lot of people don't include indium here, and that's probably rightly so, but it's usually easier to remember it as a triangle. And the triangle represents 3 plus, 2 plus, and then 1 plus, like that. So silver can be a +1 ion only, cadmium can be a +2 ion only, zinc can be +2, and then aluminum and gallium and indium are all +3, although it turns out indium can usually make a +1 ion in substance. So that's why it doesn't really belong in there, but it's easy to remember the triangle shape, and so that's why I just include it. So, and scandium actually can also be +3. All right, so let me just say one thing, right? In the old periodic table, the ones that guys like me learned when we were going to school and we were the age of guys like you or gals like you, this is 3B. This is 1B. This is 2B. And this is 3A, like that. So the deal is that's why I like those numbers better, because they reflect the chemistry of what's going on in the periodic table more clearly than do the numbers 1 through 18. Okay, but some people didn't like that, and they were in charge, and so they sort of rewrote the rules of how we do those things. Okay, so you can predict certain elements from the periodic table just based on their positions relative to the noble gases. And then everything that I just wrote on there, you could take notes down here if you like. Sorry, I should have said that earlier. So the next thing we'll talk about is the masses of atoms and the element masses we see on the periodic table.